Problem 25. Suppose log base 3 of x is equal to a, log base 3 of y is equal to b. Rewrite the expression here in terms of a and b. So to do that, so log base 3 of 27 square root x divided by y to the fourth. Okay, what rules can we use here? So one rule is that we should remember that the log base b of, or b can be anything, of, let me just use, m over n here is equal to the log base b of m minus the log base b of n. So division, a quotient inside the logarithm, becomes subtraction outside the logarithm. Also, we should know log base b of m times n is equal to log base b of m plus the log base b of n. Multiplication inside the logarithm becomes addition outside of the logarithm. And then finally, we will also need log base b of m to the k. This k can come down, k log base b of m. Okay, so let's go ahead and use these rules to simplify this expression. Okay, so the first thing that we're going to do is we see a quotient here, so that we can rewrite this as log base 3 of the numerator minus log base 3 of the denominator. Secondly, we can rewrite, here we have log of a product here, so we can rewrite this product, log base 3 of 27 plus log base 3 of the square root of x. So multiplication inside of the logarithm becomes addition outside of the logarithm minus log base 3 of y to the fourth. Okay, so we use this rule. Now let's try to use this rule to simplify things. I'm going to make the following observation, that 27 is equal to 3 cubed, and that square root of x is really x to the 1/2. And so really what we have here is log base 3 of 3 cubed plus log base 3 of x to the 1/2 minus log base 3 of y to the fourth. We're going to bring down the 3, the 1/2, and the 4 here. 3 log base 3 of 3 plus 1/2, bring down that 1/2, log base 3 of x, minus 4, bring down that 4, log base 3 of y. Log base 3 of 3 is just equal to 1. Log base 3 of x, this was defined to be a in the problem. And log base 3 of y was defined to be b in the problem. So 3 plus a over 2 minus 4b. So this is how we do this kind of problem here. I'll point out that we could have stopped, log base 3 of 3 cubed. You don't have to go through the steps. You can just see that the answer is going to be 3 here. But yeah, it just is using these 3 logarithm rules makes our life a lot easier to be able to simplify this kind of expression. Okay, let's do problem 26 as an immediate follow-on here. So while solving this logarithmic equation, student wrote the following steps. There's a couple mistakes here. Let's see what are those mistakes. This is our goal. So we have log base 2 of 3x plus 1 is equal to 3. Log base 2 of 3x plus log base 2 of 1 is equal to 3. Log base 2 of 3x plus 0 is equal to 3. 3x is equal to 3 squared. X is equal to 3. Okay, so there are two mistakes here. The first mistake occurs going from this first line to the second line. The student is attempting to say that the log of a plus b, or I guess I was using m and n before. The student is attempting to say something to the effect that log base b of m plus n is equal to log base b of m plus log base b of n, but this is not true. This is not true. Log base b of m plus log base b of n becomes log base b of m times n, not m plus n. So you're not allowed to go from here to here. That is our first mistake. Okay, going from line 2 to line 3, we see that the student has replaced log base 2 of 1 with 0, and that's fine. This is true. Log base b of 1 is always equal to 0. That's fine. So now that 0 goes away. Log base 2 of 3x is equal to 3. And the student says that means 3x is equal to 3 squared. This is our second mistake by the student. The second mistake here is that the student thinks that if the log base b of x is equal to m, this is equivalent to saying that b to the that m to the b is equal to x. When really this is not right. This should be b to the m is equal to x. And so if this were a correct statement, we already said that the student has made an important mistake here, but if this were a correct statement, 3x should equal 2 cubed, not 3 squared. So at this point, let's go ahead and, so these are, I should kind of summarize the mistakes here. One is incorrectly applying these logarithm rules, and the second is forgetting the actual meaning of what a logarithm is, reversing the base and the exponent here. To correctly solve this problem, what we should do instead is that we should just instantly jump to the end and say log base 2 of 3x plus 1 is equal to 3 means that 3x plus 1 is equal to 2 cubed, which is 8. Okay, so if 3x plus 1 is equal to 8, then 3x is equal to 7, x is equal to 7/3. So that's how we would solve this kind of logarithm problem.